case, it was the factor that actually causes 0 to happen, the factor that tends towards 0. In this case, it's the factor that tends towards infinity. We're just trying to get the maximum power of that factor out. So now, let's see. X squared over x squared tends to what? 1. So this tends towards 1. It's not that you don't have to write it like this. I'm writing it like this simply to show you the general idea. Now this one, if I simplify it a little bit, it becomes 4 over x. If x tends to infinity, a over infinity. If x tends to infinity, this factor tends to 0, simply because the power is higher in the denominator of this factor. So x squared is a stronger infinity than simply x, because it's infinitely many times greater than simply infinity. And 5 over x squared again tends towards 0. The same. This tends to 0. This is actually 1 over x squared. So this also tends towards 0. But this tends to 2. So now we see that actually this limit is 1 minus 0 plus 0 divided by 2 plus 0 minus 0. So it's simply 1/2. So it's simply 1/2. So this is the kind of, yes, question?
On paper, here written s tends to minus 2.
Minus 2, that's a mistake. That's an error, a typing error.
Okay.
That must be a typing error.
That's a confusion.
Yes. Thank you for noticing. I didn't notice it. It tends to infinity. It's infinity. Yes, you should correct it on your paper. So it has to be infinity. On the paper, it's wrong. On the paper, we have minus 2, but it should be infinity. And I started with infinity, but afterwards, for some reason, that's the problem of copy-paste. Copied and pasted the wrong thing.
Another question.
Yes, another question.
When we try to find the limits of the 0 divided by 0, can we use the log rule?
No, not yet. Because you don't know the, well, formally not, because in general we haven't done the derivatives yet.
But we can use one. To find each
Well,
derivation.
probably yes. What matters is that you can find those limits. On the other hand, of course, this method also is sometimes quite useful. So
Sometimes you cannot just cancel out all the...
Sometimes, yes. In this case, I think it's easier to divide out x squared, but sometimes yes. In number 4, for example, L'Hopital's rule is messy because deriving the square root is not pleasant.
Yeah.
Deriving the square root is not pleasant. So let's consider how to get rid of the uncertainty 0 over 0 if we have something like the square root of example number 4. I didn't show you the example number 1 because this is one of those situations where we simply put in the x value and we get a nice limit value. Sometimes we do just that. We simply find the value of the function, especially if this function is continuous at that point. So exercise 4. Now this is one I love. This is one I really like. Example number 4. So if we have a radical, x tends to 5 and the ratio is 2 minus square root of 9 minus x divided by x minus 5. So if I try to put in x value 5, then I have 2 minus square root of 4 divided by 5 minus 5. which is 0 over 0. So this is an uncertainty. We don't like this. We definitely don't like this. We can't really divide out x, because as soon as I try to divide 5 by x, I get infinity. As soon as I try to divide 2 by x, I get infinity. So that's bad. That's not a good thing. This is not a good thing. So what we do here is we use the idea of the irration, of the radical, the conjugate radical. The conjugate third. In other words, if I have 2 minus square root 9 minus x, x minus 5, what I can do, this would be nice to simplify and cancel out x minus 5. Unfortunately, I don't have x minus 5 in the denominator, so I might hope to obtain x minus 5 in the denominator somehow. And to do that, what is the thing we don't like? We don't like that this difference tends to 0, and we definitely don't like the radical. So to get rid of the radical, we use the old method from school mathematics. How do we get rid of radicals? We multiply the sum or the difference by the conjugate third. In other words, if I have a difference, then I can multiply by the corresponding sum, by 2 plus square root of 9 minus x. And of course I have to multiply the denominator by exactly the same. 2 plus square root 9 minus x. Like this. This does not change the value of the function. This does not cause us any problems, because this green factor, the extra factor I multiplied, is not equal to 0. So I can multiply by the same number. The numerator and the denominator can be multiplied by the same number. Now the next thing I do is I open this part where we have the two conjugates together, and I remember that the formula a minus b times a plus b is a squared minus b squared, which means I will lose the radicals. I will lose the radicals. This is actually why we use this, why we are applying this conjugate third, when we are applying the conjugate value for this, the conjugate expression, so that we might lose the square root. And so I have 4 minus simply 9 minus x without the square root. 2 squared minus the root squared. The root squared is 9 minus x. Don't forget the brackets. Never forget the brackets. X minus 5. And the trick is do not open the other brackets where we don't have the two conjugates multiplied together, because that will only create confusion. It will make things more difficult to calculate. Don't open these brackets, because what we have here now is 4 minus 9 minus x is x minus 5. When we open these brackets and simplify, it's x minus 5. In the denominator we have x minus 5 times 2 plus square root 9 minus x. Now I can simplify. See, this is now the bad factor that causes the 0 to happen. This is the factor that tends towards 0. So I can simply cancel it out in the numerator and in the denominator. So now what I have is something with a radical. But this radical doesn't bother me at all, because if I put 5 instead of x, this will not be negative. I can find the value. There's no problem with this. So what if we have this radical there? We can find its value. It's not a bad thing to have. So it's 1 divided by 1 times 2 plus square root of 9 minus 5. 9 minus 5 is 4, square root of 4 is 2, so 2 plus 2 is 4. And we have 1/4 as the limit for this. So this is, well, slightly tricky, perhaps. Slightly tricky. You have to know what to do. If you don't know what to do, then you are stuck. I still prefer this to L'Hopital's rule. In this case, with the square root.
I think the L'Hopital rule is easier because you need to find some numbers and to multiply that. And it's like the Gaussian method, like this. You need to find something and multiply.
No, I don't have to find something. I see what I have to write. I don't have to find it. I have to find it on my paper. In other words, I have to find it on my paper. This, and I multiply by the corresponding sum, just to get rid of those radicals. I simply know this formula, as you should.
Well, you cannot always illuminate like x minus 5, illuminate at the same time. Like, not always.
Sometimes. It depends. In this type of expression, in this type of function, yes, always. If you have a function, something like this, having a radical, having something else, and if you multiply by the conjugate, if you multiply the denominator and the numerator by the conjugate, you will always be able to eliminate the zero. In this type of function, even if both the numerator and the denominator are this type of expression, it will still work. It will still work. Now, there's another situation where we might encounter radicals, a different kind of situation with radicals. For instance, in this case, it will not be 0 over 0, and it's not in the paper. Nobody cares, okay. If x tends to infinity, and we need to find the limit of, for instance, 4x plus the square root of x squared plus 7 divided by, for instance, square root of x squared minus x plus 1 minus 8, for instance. I have no idea what I'm going to get there. Oh, I know what I'm going to get there. Something like this. Looks terrible. I know, it looks terrible, this one. It's not on your paper. The difference, so normally, if I had x tends to something and I get 0 over 0, then normally I would. So the thing is, if I had no infinity here, if I had some value there, and something that makes this and this 0, then I would probably use this method, multiply both the numerator and the denominator by both the conjugates. But in this case, there's a big difference. And the difference is this part. Here we have x tends to some finite value and we have 0 over 0. So this was 0 over 0. In this case, if x tends to infinity, what we basically have is infinity over infinity. Because if x tends to infinity, then x squared tends to infinity, and if x squared tends to infinity, then the square root of infinity also still tends to infinity. So in this case, we have infinity over infinity. But remember what we did with those infinity over infinity examples. We had to divide out infinity, divide out the greatest power of x. What is the greatest power of x here?
X.
Simply x. Simply x. Because roughly speaking, we might say, okay, this is approximately the first power, degree of power 1. X squared and then the square root of that. It's approximate. Of course, it's not exactly x to the first, because it's x squared plus something and then the square root. But approximately, we can say that these two together create the first power, power 1. So the same happens here. So the maximum power is actually x to the first power. So I will try to divide out simply x. Simply x. And let us see what happens. Lim, when x tends to infinity, 4x over x plus square root of x squared plus 7 over x, square root of x squared minus x plus 1 over x minus 8 over x. Like this. Simply dividing everything by x. Notice that in the first step, I take the square root as a whole, one single unit, and divide it by x. In the next step, I'll try to push this denominator x into the square root, and let's see what happens. So we have lim when x tends to infinity. Oh, I am very sorry to disturb you, people. I will shut up in just a few minutes, in just a few moments. 4x over x is just 4 plus now this. If I divide by x, but if I want to put this x into the square root, how do I carry a factor or a divisor under the root? It becomes x squared, right? Because I can think that x is the square root of x squared. So if I want to push this under the root, I simply make it a square. And so this becomes x squared over x squared plus 7 over x squared. So I'm doing it slowly. So if I want to divide by the same power of x, I have to double that power in order to get it under the root. Remember how we carry the factors into the radical, under the radical sign. We square them. And so the denominator becomes square root x squared over x squared. This becomes x squared inside the root minus x over x squared plus 1 over x squared minus 8 over x, still the same. And now let's see. This tends to 0. This tends to 0. This, because the power is greater, the exponent is greater, the denominator tends to 0. It's like 1 over infinity. And this tends to 0. So what I have now is 4 plus square root of what? 1. 1. Okay, I will write 1 plus 0 there. Divided by, this is 1, minus 0, plus 0, minus 0. I'm simply, you don't have to write all those zeros. As long as you can keep track of everything you do, you don't really have to write those zeros. I'm writing them simply to show what they represent. So this 0 stands for this term, which I noticed tends towards 0. And these 3 zeros stand for these terms. So what I have is 4 plus 1 divided by 1, and the limit is 5. And the limit is 5. So when you have a limit involving radicals, one of the most important things, one of the first things you have to look at is towards what does x tend? It's important. Where x is going, the whole limit might be going. So you might have two limits that look almost the same, but for this. X tends to infinity, or x tends to 3, or x tends to minus 1, or something. So you must always pay attention to this, because the method of solution may depend on this. The method of solution may depend on this. Well, usually it does. Alright. The other side, 27 limits. Okay. You may start working. And yes, you may hand in the homework. And yes, there are some other questions with which I hope to be able to deal. Okay, staple these together. I think in a minute or two I will need more staples. Okay.
Shut it down?
It doesn't really. What is the sign? See, it doesn't exist if I put minus 2 there. If I take minus 2 to some number,